Next in the polymers, it is the natural rubber. So for example, this natural rubber can be obtained from the variety trees. It is called as a latex trees. So the natural rubber can be obtained from the latex trees. So here this latex trees, we can obtain the natural rubber. So this natural rubber empirical formula is the C5HA. The empirical formula of natural rubber is C5HA. So from that we should conclude that natural rubber is a hydrocarbon, because when we observe its empirical formula, the carbon and hydrogen will be present, and we do the simple experiment in presence of the air. When we heating this natural rubber, it will give the carbon dioxide and water. From that experiment also, we should conclude that natural rubber is nothing but hydrocarbon. If it is heating in absence of air, natural rubber in presence of air, on heating it will give the carbon dioxide and water. If in absence of air, if it is heating, it will give the isoprene units. The natural rubber will give the isoprene units. So isoprene means nothing but the chemical name of isoprene is the 2-methyl 1,3-butadiene. 2-methyl 1,3-butadiene will be called as a isoprene. So its chemical structure is the CH2 double bond C CH3 bond CH double bond CH3. So 1, 2, 3, 4. 1,3, 1, 2, 3, 4 butadiene. On second position, methyl group is present. So simply that is called as a 2-methyl-1,3-butadiene. This is the alkyl name for the isoprene, and the common name is the isoprene. So from this, we should conclude that natural rubber monomer is the isoprene. What is the natural rubber monomer? Name is isoprene. The chemical name of isoprene is 2-methyl-1,3-butadiene, and its chemical structure is this one. When we observe the natural rubber, in the natural rubber, the all isoprene units are arranged in the cis form. In the natural rubber, all the isoprene units are arranged in the cis form, just like this one. CH3, C, CH2, double bond C, H, CH2, CH2, C, CH3, double bond CH2. So all are present in the cis model. All are present in the cis form. So when these isoprene units are arranged in the cis form, due to this nature, the natural rubber will be having the elastic in nature, highly elastic in nature. Natural rubber will have the highly elastic nature. The main reason for that highly elastic nature for natural rubber is, in the natural rubber, the monomer isoprene units are arranged as a cis model or cis form. So when they are arranged in the trans form, the natural rubber will be losing their elastic nature. Isoprene units are arranged in the trans form. The natural rubber will be losing their elastic nature. So for example, if isoprene units are arranged in the trans form, so that form is called as a Gatta Acha. So natural rubber isoprene units are arranged in the cis form. When they are arranged in the trans form, that is not called as a natural rubber, that will be called as a Gatta Acha. So this is about the natural rubber and monomer of the natural rubber and how they are arranged in the natural rubber. We move to the vulcanization of rubber. So natural rubber will be having the most elastic nature. So when the rubber will having that most of elastic nature, there is no use of that rubber. So we are minimize the elastic nature of the rubber. How we can minimize the elastic nature of rubber means just we should do the vulcanizing of rubber. Simply that is called as a vulcanization of rubber. So what is the main use of vulcanization of rubber means just we should minimize, decreases the elastic nature of the rubber. So that is called as a vulcanization process, nothing but vulcanization of rubber. So what is the mean by the vulcanization of rubber? Simple, we are adding the sulfur atoms to the natural rubber in the presence of the 373 to 415 Kelvin temperature. That process is called as a vulcanization of rubber. Vulcanization of rubber means nothing but the rubber is heating in presence of sulfur at 373 to 415 Kelvin temperature. That is called as a vulcanization of rubber. Generally, 5% of the rubber is added, 5% of the sulfur is added to the rubber. Generally, how much rubber is vulcanized with sulfur means generally 5% of the sulfur is added to the rubber. So, what about after vulcanization of rubber means just the sulfur is formed the cross linkages in between the monomeric unit. Sulfur is formed the cross linkages in between the monomeric unit like this one. So this is the normal monomeric unit. After vulcanization the sulfur will be formed with the bond of this monomeric unit. Sulfur. Simply this is called as a cross linkages. Sulfur is cross linked with the monomeric unit. Due to this cross linkages, due to this vulcanization process, due to this vulcanization of rubber, natural rubber will be losing their elastic nature or minimize their elastic nature. Then that vulcanized rubber is used as a automobile industries. Just like the automobile industries, they can be used for preparation of tires and they can be used for the preparation of the tubes. So this is the meaning about the vulcanization of rubber. Simple, vulcanization of rubber means just we are adding the sulfur to the natural rubber at 373 to 415 Kelvin temperature. That process is called as a vulcanization of rubber. Generally, 5% of sulfur is used for vulcanization process of rubber. So, why we do the vulcanization of rubber means just the minimize the elastic nature of rubber. After vulcanization, the sulfur will be cross linkages in between the monomeric units of rubber. So these vulcanized rubber can be used in automobile industries like tires and tubes can be prepared from that vulcanized rubber. For example, if sulfur percentage will be increases, the hardness of rubber is also increases. Generally, how much sulfur is used in the vulcanized process means 5% of sulfur is used in the vulcanization process. For example, if 45% of sulfur is used in the vulcanization process, then that material is called as a ebonite. What is that? That material is called as a ebonite. Ebonite means nothing but 45% of sulfur vulcanized rubber will be called as a ebonite. This is about the natural rubber. Then we move to the synthetic rubber. Synthetic rubber means simple. It can be synthesized in the laboratories by man. And nothing but man-made rubbers will be called as a synthetic rubber. So the general examples for the synthetic rubbers is the neoprene and buna rubbers. For example, when we observe the neoprene, so the monomers of the neoprene is the chloroprene. So this is the chloroprene structure, CH2 double bond C bond CH bond CH double bond CH2. Its chemical name IUPAC name is the 2-chloro-1,3-butadiene. Neoprene synthetic rubber. It is the example for the synthetic rubber. Its monomer name is the chloroprene, that is the 2-chloro-1,3-butadiene. When we observe that this neoprene synthetic rubber, only how many types of monomers are present? Only one type of the monomer will be present. So it is called as a homopolymer. Already discussed the homopolymer. Homopolymer, copolymer means only one type of the monomers are present. That type of polymer is the homopolymer. Different type of the monomers are present. That type of polymer is called as a copolymer. For example, in the synthetic rubber, neoprene is an example for the synthetic rubber. Its monomer is the chloroprene, 2-chloro-1,3-butadiene. Means only one type of the monomer will be present. So it is also called as a homopolymer of synthetic rubber. So this neoprene can be used in the preparation of belts and gaskets. It can be used for preparation of belts and gaskets. And another example for synthetic rubber is the Buna rubbers. So on the Buna rubbers, Buna S is present. Similarly, Buna N is also present. These are the examples for the synthetic rubbers, Buna S and Buna N. For example, in Buna S synthetic polymer, synthetic rubber, the monomers is the 1,3-butadiene and styrene. 1,3-butadiene and styrene. 1,3-butadiene means CH2 double bond CH, bond CH, double bond CH. At first carbon, at third carbon, two double bonds are present. So 1,3-butadiene. Styrene means C6H5 bond CH, double bond CH. It is the formula for the styrene. So these are the monomers of Buna S like a synthetic rubber. When we observe this Buna S synthetic rubber, how many types of monomers are present? There are two types of monomers are present. One is the 1,3-butadiene, another one is the styrene. Means different type of the monomers are present. So Buna S is example for which type? Copolymer. It is example for copolymer. So this is the few examples of the synthetic rubbers.